Welcome to an introductory webinar created by NetScout. In this webinar, we'll be looking at high-performance test labs. Specifically, we'll look at the characteristics of a high-performance test lab, we'll examine the challenges being faced today, and then we'll introduce an innovative approach to optimizing high-performance labs. Let's take a look at the characteristics of high-performance test labs. These labs are in the critical path when it comes to the release of new products and services. Often, they represent the last step before a solution hits the market to begin producing revenue for an organization. Additionally, these products or services are frequently meant to be released across multiple hardware and software platforms, so the burden really falls on the lab to perform a multitude of tests on these solutions in order to assure that they're ready for release. For this reason, labs have invested heavily in tools to perform this testing. Not only do the platforms evolve over time, but network interface speeds continue to increase. So high-performance test labs need to keep pace with new technologies, while at the same time maintaining the capability to test with legacy interfaces. Many labs need to validate products at different speeds, including 1, 10, 40, and 100 gigabit rates. And test labs are seeing the time frames they're allotted to complete testing shrink over time, but the pressure to bring products and services to market quickly is ever increasing. To meet these challenges, labs acquire more and more tools to test across more and more platforms, all while under intense schedule pressures. This, of course, leads to a tremendous increase in the complexity of the lab. There are many opportunities for optimization in the high-performance test lab. A typical lab is made up of test tools, supporting infrastructure like patch panels and cabling, and the systems under test. In this diagram, Site 1 has some 10 gigabit test tools that are not being used. They aren't even cabled into the infrastructure. Site 2 needs more 10 gigabit test tools, and this is preventing a test cycle from starting. In terms of CAPEX savings, labs are always looking to add new test tools. If we can find a way to reduce the expenditure on these tools, it would result in a significant savings. And further, if we could find a way to more efficiently use the tools already in the lab, they'll be able to realize a return on investment for those tools much more quickly. Another way to save on the CAPEX side would be to find a way to increase the lifespan of existing test tools rather than constantly purchase new ones. On the OPEX side, sharing test tools between physical sites provides an opportunity for significant savings. If we can increase the speed of topology changes and avoid having to bring staff in to recable infrastructure for different test scenarios or different products or services, we could greatly decrease operational costs. Every test lab needs the means to analyze data when tests don't go as planned. Without an optimized infrastructure, gathering test stream data feeds can be a cumbersome process. Providing the test engineer with data feeds in a timely manner can result in significant savings. Let's look at the keys to success when optimizing high-performance test labs. First is the ability to increase utilization in order to improve the performance of the test lab by making people more effective and using the infrastructure more efficiently. The second key to success is to reduce the time it takes to complete test cycles. If we could eliminate making manual topology changes through automation and reduce the wait time for test tools to become available, not only would this reduce the time to test, but it would also make the lab generally more efficient. And the last key to success in high-performance test labs is the ability to reduce the spend on test tools and at the same time increase the effectiveness of the test. It is a well-proven fact that finding problems with products or services in the test lab is far more cost-effective than finding them in the field. So doing a better job in the lab can be key in providing significant cost savings. Now let's talk about a NetScout approach to optimizing high-performance test labs. The NetScout solution sits at the logical core of the lab and enables remote configuration and management. It promotes the efficient use of test tools, and it provides Layer 2 through 4 functions to increase lab performance. This NetScout solution improves the efficiency, speed, and performance of network and application test labs. This is done by combining Layer 1 switching with Layer 2 through 4 intelligence in scalable configurations, all controlled by easy-to-use application software or third-party tools. Combining Layer 1 switching with Layer 2 through 4 intelligence enables lab managers and test engineers to access functions that would otherwise require additional equipment. Supplying higher-level functions along with Layer 1 switching simplifies the test configuration and reduces variability in test execution. These functions can be applied to any test stream and without the need to physically access the lab. Let's take a closer look at some of the functions. First, we have Layer 1 switching. Layer 1 switching enables lab managers to quickly build test topologies from pooled resources. This greatly improves the availability of test tools and increases the speed of topology changes. Since all configuration changes are done remotely via software, downtime caused by failed cables and dirty connectors is nearly eliminated. Our next example looks at a very common occurrence in testing, the need to analyze test streams using a tap. Test engineers often need to analyze live test streams in order to diagnose problems. This can be accomplished using a physical tap or by establishing a mirror port on a switch. These solutions are less than ideal in some scenarios where physical access is not an option, or mirror ports might not be available, or might have adverse effects on the test itself. NetScout's solution allows users to apply a tap to any test stream without requiring physical access to the lab and without impacting the test. Additionally, the user can apply Layer 2 through 4 filters on the tap traffic in order to reduce the load on the analysis tools. Having tap and filter capability built into the infrastructure increases the speed of the analysis and debug cycle, therefore improving the efficiency of the test engineers. Creating background load is an important mechanism for conducting effective performance testing. By using the replicate function, test engineers can create significant background load on a system under test without purchasing additional test tools. By refining the replicated test stream with Layer 2 through 4 filters, the additional load can be varied as required by test objectives. This improves the overall quality of the test, especially in cases where background load is not being applied today. Testing real-world scenarios using impairments or negative testing is often overlooked due to the lack of tools or time constraints related to the manual nature of cable pulls. Using the built-in port flapping function, test engineers can effectively simulate failure modes on any port in the system. This is achieved using software controls, so physical access to the test bed is not required. Testing with impairments improves the overall quality of the test and should not be overlooked in high-performance test labs. This webinar has outlined the characteristics, challenges, and keys to success for optimizing high-performance test labs. NetScout's test optimization solutions offer Layer 1 switching with Layer 2 through 4 intelligence. Our solutions play a vital role in ensuring that cost drivers are addressed and efficiency is improved through increased utilization of test tools, a reduction in the amount of time required to configure and tear down test topologies, and money saved on test tools and infrastructure. Thank you for listening to this webinar. For more information, please contact your local NetScout account manager or visit www.netscout.com.